Hi, my name is Sam Farajzadeh, and I'm representing my team on behalf of our Capstone project named Neurotask. Let's get started. Our project deals with an issue where patients with neurodegenerative diseases have an inability to pay for cognitive testing but need frequent testing. Our product is designed to allow these patients to have the testing that they need while also providing diagnostic research testing or research information for researchers that enable them to provide information to those clients. Our system is a rebuilt version of an existing system that Mosaic Lab had built using Dart, Flutter, and Firebase, but since the application already had poor visibility, maintainability, outdated dependencies, it eventually stalled our ability to implement and update the product with the new changes that we would like to add. So we decided to rewrite the entire application using dry principles, basically trying to reduce the amount of repeated code within the entire project, and implemented a modular MVC architecture that created a smooth development environment and development flow for the developers and future developers. Our product requirements basically are to rebuild all the game's original functionalities, try to re-implement these games and the entire product in a way that is maintainable and allows for better readability, and provide a framework that avoids having the developers implement each new game manually into the main menu. Our new framework allows for constant time effort so that when you implement a new game and it's all done, all you need to do is plug it in one time in one spot, and then you can instantly access it wherever you need from the rest of the project dynamically, which drastically reduces implementation time for larger features like the main menu. Our game has several key features. Two categories of main features: the cognitive games and the data collection. We have 7 base games that collect data based off the user and are used for diagnostic information from our researchers: grandfather passage, narration test, color test, connect the dots, memory game, target game, and visuospatial test. These all collect rather different aspects of information from each test and each user, so they're valuable to have in the project. And as a base for right now, our data collection only is capable of collecting accelerometer and gyroscopic data, which is a through line through all these games because we want to know how the user is responding physically to reading or performing the requested activities in each of these games throughout the duration of the test. It provides important information to the researchers, so we implemented this first. All of this information is being streamed live to a Firebase database that has user authentication and structured medical data based off the information collected from the test. Our system design and architecture follow a MVC controller pattern, MVC pattern, and uses Flutter and GetX for one, allowing multiple platform compatibility with Flutter, and GetX for smart and efficient state management that enabled us to create that new framework for constant time effort for implementing our new games into the rest of our project. The backend is rather simple. It's mainly just Firebase using multiple services from Firebase, which is the authentication, the Firestore, and then the database storage for all real-time data collection. And as previously mentioned, it does allow us, or Flutter does enable us to use iOS and Android compatibility for a broader range of users. These are 2 UML diagrams of our memory game. Essentially, the image on the left shows a use case where the user has opened up the game and is deciding all the options that they have to use the application. So the user initially opens the game, then it provides a instruction manual, then you can click start game, and then the user goes into a game loop until the game is completed, during which the game collects data based off their movements, and then once the user beats the game or finishes the game, the data is saved and then uploaded to Firebase. The image on the right is essentially the same thing I just described, but just a more linear flow rather than a open possibility of all the options the user has at once. Next is our data model principles that we use during the project. We try to set all the data to be user-centric, meaning that all the data collected is identified by two things: a user account, which is authenticated through Firebase, and a session. So every time a user logs in or enters the application, it creates a new session, which creates a unique ID that is linked to all the data collected in that specific session, which can help the researchers identify unique or unusual performance in any given play session. Firebase also allows us to do real-time data collection, so it provides a more accurate collection of data during the duration of the test. And we try to have the data collected be clinically ready, meaning that the data is organized as much as possible, including timestamps and metadata based off the user. And for the conclusions, we essentially gather all the information from the cognitive games, and it enables researchers that use this data to create better insight on how to treat, diagnose, and identify neurodegenerative diseases. And our refactoring of the entire project has enabled us to streamline the development flow and allow future developers to not only understand the project structure more easily, but to better implement and begin implementing new features much quicker. Our future scope is to ideally provide an expansion on more data collection or more access to sensors in the phone or device of the user to better collect more data, which can provide better ability for the researchers to diagnose or provide insight onto whatever the user is experiencing. We also would like to add more games to provide a more varied, more variety of data collected for the researchers. Thank you so much, and I am finished.